one of the other things I went to explore in the Flagsmith code was the idea of where the flag rules are being evaluated. So for that, excuse me, I searched on the Flagsmith client. So you have an SDK for every client, for quite a few number of languages, so that they can be used with the API on the Flagsmith side. And from what I understand, and correct me if I'm wrong, the SDK will download the identity from the from the API itself, and the identity contains the traits and the feature flags. Is that correct?
So, well, so the SDK generates was the identities are kind of lazily created, and the traits are lazily created and persisted the first time they're seen. So you can, if you're using the same identity across two different, like let's say you've got a web application and a mobile application, if they're using the same Flagsmith project and you're using the same identifier, then those traits are kind of shareable between those two platforms. So because we persist those traits within our database, so the SDKs send that trait information up to the platform, but you can kind of you can think of it as like a sort of a little data store for your users, basically. So if I write a bunch of traits to my user in the mobile application and then open a web application and grab the identity with the same identifier, those traits will also come down to that platform. So they kind of allow you to have a consistent view of an identity across different platforms. But the other really conceptual thing around flags is, like you said, yeah, where does that engine run, right? And when we built Flagsmith, we decided that, and it's actually interesting because we're about to do a bunch of work around this, but we decided that the flag engine should run within our server. And so that's different to some of the other projects out there. And some have got a hybrid approach now, but we didn't want the flags to be evaluated on the client. And the main reason for that is that for them to be evaluated on the client, all of your segment definitions and all of the data around your environment needs to be sent to the client. So, and then the client brings the data and the flags get evaluated and the rules engine runs within the client. One of the reasons we didn't want to do that was because we didn't want to re-implement the rules engine in 12 different languages, even though that would have been a really fun engineering process. But the main reason is that we were like, well, if let's say I create a segment called, like, bad customers, and then identify the rules, create the rules that define what a bad customer is. If someone logs into my platform and grabs the environment and has that rule engine run in their browser, you can just go open the browser console and say, okay, well, show me this JSON document that Flagsmith just sent me, and all of a sudden you've got access to, this definition of bad customers. And so that idea of leaking that environment data to, because our SDK API is public, right? Like you can grab the Flagsmith flags using a curl endpoint, or and anyone can do it. By design, there's no authentication around that. And so we just thought that was a really and it's also something that an engineer might not consider as a potential sort of security weakness. And so we just thought it was a bad idea. And then also it means that you don't have a single REST endpoint to grab flags, right? Like, because you're not grabbing flags, you're grabbing a bunch of rules, and then you have to run some compute to get your flags. And so we were like, well, no, I want a REST endpoint that sends me my flags and nothing else. So our SDKs have no notion of segments or traits or anything of that nature. They just get flags. Now, I talked about the reasons why you might not want to have the rules engine on the client. But one of the problems with that is that you have a latency hit every time you want to get flags. And on a client side device, so like on a web browser or mobile application, that's not too much of a big deal because you generally grab that data when the application's starting up or when the mobile application's starting up. But if you're using them server side, it can be painful. And so what we're actually doing now, and this is kind of following on a little bit how LaunchDarkly do it, who are like the big kind of elephant, gorilla, whatever you want to call it, massively well-funded company. They've got a really good product, is they have a hybrid. So the runtimes that you don't control, which would basically be the mobile apps and the web browser, they have server evaluated flags. So they just send the flags to those clients. The runtimes that you generally do have control over, which is generally the server side runtimes, they then send all the segment definitions down to, let's say you're writing it in Java. So you're writing a Java microservice. You grab the flag meta, you grab the environment's meta information, and you store it within your Java environment, which is secure, or you hope is secure. And then you don't have to, when a request comes in and says like, okay, what is this feature on or off? Because the SDK has that rule engine built in and it has those rules there, it can then evaluate that without having to make a request out. And that's what we're working on next, is we're working on building this rules engine and implementing it in these 12 different languages. But what's interesting also is we're about to release a beta feature, which we've been working on all year, which is an Edge API for our SDKs. So, one of the problems that our customers had was, if you're requesting your flags and you're sat in Sydney and our data centers in Europe, you have to wait, your latency hit is kind of painful. If you're in London, then it's not so bad. So what we've done is we extracted the rules engine and we've implemented it as a Lambda. And then we're using Lambda at Edge and DynamoDB to provide an Edge network for those SDK calls. And we're literally about to start offering that up as a beta feature to our customers. So, but we had to extract the rules engine from the Django project in order to do that, because it runs as a Lambda. So it's kind of fun now. You can look on GitHub. We've got a repository called the Flagsmith engine, and it's about 600 lines of code. And it is that entire engine basically. So that's extracted out, and that's now part of the Lambda as well as the core API. But now we've got this 600 line implementation in Python that we need to rewrite in Elixir and Go and Rust and all those fun languages. So yeah, but that's one of the main fundamental differences between the products out on the marketplace, is how they try to deal with that problem of where those flags get evaluated. And it's actually a difficult problem, because you've either got a latency performance here, or you've kind of got a sort of like a security issue, or something that, something you need to be aware of as an engineer. And we really didn't want to increase the mental load of the people who are implementing the platform, having to worry about, where's this being, they've got enough to worry about. So yeah, so that's what we're working on next, is implementations in those languages. So if you like writing Elixir and you fancy a fun weekend project, then it's waiting for someone to do it, basically. Yeah.
So basically a hybrid approach. I mean, you started with, if I understand correctly, so that's the Flagsmith client, and the identity, from the identity, you just make one call and you get the flags automatically.
That's right.
So that's, I guess that the idea behind that is really just to minimize the latency and just have one call, and then you can cache that on the client side so that it doesn't have to make any. Okay, got it. And then on the server side, you have it seems a few endpoints that are used by the client SDK. The identities one is the main one that allows downloading of the identity. I was curious, what does the flag one do?
Yeah, so that just gets the environments flags. So if you don't care about, so generally if it's like an anonymous browser, let's say it's your homepage and, it's just an anonymous browser. You don't really care about that browser. You don't want to track it. You don't want to run an A/B test. You can just ask for the flags for that environment, which are the default flags that you see when you log into the Flagsmith dashboard, basically.
I see. So you don't need to, the identity that matters less in that situation, in a sense.
Yeah, if you just want, if the context of that request is you don't care about the person making it or the entity making it, you can just request the flags for the environment. Actually, interestingly, I think probably 80% of the calls to our SaaS API are for identities, and about 20% are just for an environments flag. So yeah, the majority of them are people requesting flags for a particular individual, because that's generally, it makes kind of most sense, right?
Right. No, that makes a lot of sense, and that you optimize the latency for that. So I think it's like the get identity feature. Here we have a bunch of tests. I'm going to ignore those tests. Let's see what we get. And this is the main call that does the main call for getting the identity, and from where the rule engine.
Yeah, it looks like it. Yeah. How long does it take? How long does it take Quod AI to index all this stuff?
Just a few minutes. Yeah, just a few minutes. It depends on the size of the repository. So, but on average, it'll take about 10 to 20 minutes on the, I would call it mid-size repo.
Yeah. Okay. Yeah, it's really interesting.
Thank you.
Yeah, it's good because I can never find that code.
Yeah, no worries. Cool. If you too like to debug in production, give us a like, comment, or subscribe. Thank you.